So to add these two fractions, we have to have a common denominator. Because we have a common denominator, we can distribute the negative sign and go with it. Now we can simplify what's up top. What's 3a minus a?
2a.
2a. Negative 2 plus 6
Plus 4.
is plus 4. And the denominator is a plus 2.
How did you get it to that one big fraction?
Did you
You
cancel
just
out
use
the
the
2s
parentheses
and
to-
the 8s?
No, we can't. George, the denominators are the same, so you combine the numerators and you keep the denominator the same.
Okay.
How did I get this to one?
You did the parentheses.
How did I get this one to one big fraction?
You just combined.
I did 2x squared plus 3x squared over 20x, right?
It was the parentheses and it looked like you were distributing the active.
I am distributing. I'm distributing this negative sign to that and to that.
Oh, that's you got a plus 6.
Okay, so did you miss that whole first part? That whole first part was
Got it now.
the fraction bar is a grouping symbol, so the negative sign in front of the fraction has to be distributed to the numerator. And that's always going to be the case. And that's always going to be where you miss these problems if you're not careful. And we're not finished with this. Why are we not finished?
We have to factor the numerator.
Because we can take a 2 out of the numerator. And the a plus 2's can cancel, and we're just left with 2. Now, here's the deal. Jay, your question was, can we cancel the a's and can we cancel the 4 over 2? And the answer is never. You can't cancel things that are being added or subtracted. You can only cancel things that are being multiplied. Now, a plus 2 here is being multiplied, right? It's being multiplied by this 2, and so I can cancel it. Is this a being multiplied? It's a part of a term, right? You can only cancel factors. You can't cancel things that are being multiplied. Yeah, but that's what is 2a? 2a is a term. You can't cancel a term or a part of a term. You can only cancel something that is being multiplied. Now, this 2 is only being multiplied. It's not being added to anything. This a plus 2 is only being multiplied by this 2, so they're factors. You can cancel factors, but you can't cancel terms or parts of terms. Last example in this set, this one's a little bit more complicated, right? Z squared minus 10, z cubed minus 10z squared. 10z. That would be kind of a neat name. 10z. There's a game what? 10z. Z cubed minus 10z squared over z squared minus 3z minus 18 plus 4z squared. Now, the numerators are the same again, so we can combine the numerators. All right?
That part to the right, is that part of the problem?
That's the last problem. So I can add the numerators. Are we okay to just combine those two like terms? Right here. What's negative 10z squared plus 4z squared?
Negative 6z squared.
Negative 6z squared. And then my denominator is z squared minus 3z minus 18. But we're not finished yet. We have to determine if this can be simplified. How do we simplify rational expressions? By canceling what?
Like terms?
No, we can't cancel terms. Holy smokes. We can cancel factors. Okay. How do you find the factors? By factoring. What can we factor in the numerator?
You can factor.
Not 2, just z squared times z minus 6. Right? Good. Now, what's the factorization of z squared minus 3z minus 18?
Z minus 6 times Z plus 3.
Very good. You see how factoring is such an important skill, right? It's in everything in Algebra 2, college algebra, we factor. Trig, we factor. It's factor, factor, factor. Now,
Okay, so Z minus
Z minus 6s can cancel because they're common factors.
X can cancel, right? No, that's right.
There are no x's.
I mean Z.
Z squared over Z plus 3 is what we have. I can't cancel, Jay, look at me. I can't cancel that Z with that Z because this Z right here is what? It's a term. It's being added to 3. That's locked together. You can't cancel a part of a term. You can cancel the whole thing or nothing. So my final answer is Z squared over Z plus 3. Okay? Let's get a little bit more complicated here. There's a couple of ways around this problem, but let's just shoot straight and do what it says right here. Let's find the sum by getting a common denominator. Denominators make the denominators the same. And we can only do that by multiplying by 1, right? The only thing I'm allowed to do to a term is multiply it by 1 or add 0. So what can I make these denominators?
You can cancel one of the h's.
No. We're gonna be proactive. Instead of canceling, we're going to be proactive.
6h squared.
6h squared is what I need, right? At the end of the day, what you were suggesting is not going to save us a lot of time, if any. And I'll show you in a second. I don't really have time. 6h squared is what I need. So what do I need to multiply the left by?
H.
H over h, right? Which is, I'm multiplying by 1. What do I need to multiply the right by?
3.
3 over 3. So that's going to give me 2h to the 5th over 6h squared plus 4h squared over 6h squared.
Wait, you didn't multiply. Yeah, you didn't multiply the 4.
12, thank you. Very good. So that gives me 2h to the 5th plus 12h squared over 6h squared. And I'm writing an equal sign here because we are not done. Why are we not done? I have to factor to see if anything can cancel, right? What can I take out of the top?
H.
A 2 and an h squared. And that'll leave me with h cubed plus 6. And in the bottom, 6h squared. All right. Now, what can cancel?
2h squared.
2h squared can cancel. And I'm left with h cubed plus 6 over 3. Wilson, if you can cancel at the beginning and make your denominators the same, you can save yourself some time. But we can't. Right?
Wait, I said cancel.
No. I know I'm not suggesting what you said, but if we cancel things, we still have to multiply them both to get a common denominator, or 1. And we still have to factor at the end and simplify it there. So you don't usually save yourself time by canceling anything at the beginning of one of these problems, unless by canceling we can actually make the denominators the same. All right? Your instincts would have gotten you to the correct answer, just not any less work. All right? We've got to finish this problem. We're getting short on time here.
Is the denominator 3h to the second?
I don't know.
It's just, they finally replaced
It's just 3. The h to the seconds cancel. Wow, you're that far behind, George?
Well, no, I was working it another way, and then I realized.
Gotcha. Okay, now we've got x plus 3 over x minus 4 minus 2 over x squared plus x minus 20. If I get a common denominator here, I need the least common multiple, right? And to find the least common multiple, I need to see the factors of things. So my fraction on the left, x minus 4, can't be factored, so it's going to stay the same. what is the factorization, and you'll see the importance of being able to do this quickly. What is the factorization of x squared plus x minus 20?
X plus 5 times x minus 4.
Yes, x plus 5 times x minus 4. No. Well, they're not even numerator to denominator, and there's a minus sign right here. You can only cancel things that are being multiplied, factors. Okay, this is two terms. We can't cancel anything between these two terms ever. All right, terms are off limits for canceling. Only factors can be canceled. All right, I can make my denominators the same though. What do I need on the left to make these two denominators the same? I need to add a factor of x plus 5, and I can't do that just in the bottom. I have to do it in the bottom and in the top.
Now you add that factor or you multiply?
It's multiplying. We're not adding. The only thing we're allowed to add is 0. We can multiply by 1 though, so what we're multiplying by is 1. When you do multiply here, Georgie, you get
X plus 5, x plus 3.
x squared plus 8x plus 15 minus 2 over, never multiply denominator back together. Always leave it factored. Always leave it factored. Because what can we see quickly from x plus 5 and x minus 4? Can't we see excluded values here? What can x not be in this expression? Negative 5 or positive 4. So if we were graphing this thing, we can see the vertical asymptotes immediately, negative 5 and positive 4. This one has two vertical asymptotes, unlike the ones we looked at in last unit. So I've got here x squared plus 8x plus 13 over x plus 5 times x minus 4. Now how do I know that the numerator can't be factored? Yeah, nothing multiplies to be 13 that also adds to be 8. I mean, 13 and 1 we could factor it, but that doesn't give us 8. So that is the final answer.
Would you not unfactor? Would you not solve x plus 5 x minus 4?
No, again, we never multiply a denominator back together. Always leave it factored.
Okay.
So we keep the b busted in the numerator and doing that. The middle term.
The middle term is 8x.
Oh, yeah.
Yeah, we're not busting the b because we're not factoring it. All right. Now this one, I need you to see one caveat on this problem, and then this might carry us into the bell. Are v minus 4 and 4 minus v the same? You need to write this down. They're not the same, are they? What's their relationship?
Conjugate.
They're not conjugates. Conjugates are different by one term. Opposites are different by all terms. So 4 is positive, 4 is negative. V is positive, V is negative. These are opposites of each other. So what we have to do here is 8 over V minus 4. Pull out a negative and change the sign.
Where'd you pull that negative from?
From the denominator. I factored a negative out.
Oh, okay, I see. You flipped it.
Okay, so then I would have 8 minus V plus 7 over V minus 4, which simplifies to be 15 minus V over V minus 4. Can anything cancel? Can I cancel those V's? No, because they are terms. Sorry for keeping y'all late.